Hello, today we're going to be learning about transforming functions with Kamil Moroz. So the basic transformations are up, down, left, and right. The very first transformation, we're going to be starting with a simple x squared, f of x equals x squared function. So if we want to transform the function up, we need to change the result. So you add 2 to the outside. And what happens is that the original f of x function goes up 2 units. And it begins to look like this. While if you want to make the function go down, you do the opposite, which is subtracting 2 units. Left and right is slightly more complicated, where what happens is you need to you have to add and subtract from the x directly, but it's also opposite. So if you want to move it to the left 2 units, you need to add 2. And what's going to happen is it shifts to the left 2 units. While if you want to move it to the right, you need to subtract 2. Now, the changing the x in the total equation is also going to come into horizontal stretches and vertical stretches. Now, for horizontal stretches and horizontal shrinks, we're going to be changing the input. So if we're going to shrink horizontally by a factor of 2, we are going to multiply the x by 2. And what this happens is that the original points on an x squared graph are 1, 1, 2, 4, 3, 9, 4, 16, etc. Now what's going to happen is our input is going to be multiplied by 2. So what's going to happen is this is going to become 1, 2. 1 times 2 is 2, and then 2 times 2 squared is 4. So it becomes 1, 4, and then it becomes 2, 16, etc., etc. So the graph appears as if it's going to be shrinked together. And it begins to look like this. While if we're going to stretch the graph, we're going to be multiplying by a factor greater than 0, but less than 1. This is essentially dividing x, since multiplying by 1/2 is the same as dividing it by 2. Now the original points, 1, 1, you input 1, it becomes 1/2, and then you square 1/2, so it becomes 1, 0.25. Multiplying 2 by 1/2 becomes 2, becomes 1, and then 1 squared is 1, so the new point is 2, 1, etc., etc. So the new graph begins to look much more broader as it stretches out, where it begins to look like this. Vertical stretches and vertical shrinks are essentially the same thing. What happens, however, is that just like moving the equation up and down, you need to multiply the result, and you need to essentially divide the result. So we multiply the outside of the x squared. Now, as we saw before, the original points, what happens is that you essentially just multiply it by 2. So the new points become 1, 2, 2, 8, 3, 18. Now, it kind of looks the same, as if you just horizontally shrinked it. But for the vertical stretch, you're elongating it upwards. And the points are obviously different. And of course, the other side is the same because it's a squared function. If you're to shrink it horizontally, it also appears as if it just got broader. So we're going to be shrinking by a factor of 2, which is like dividing the result by 2. And then the new points become 1 comma 0.5, because 1 times 1/2 is 1/2, 2 comma 2, because 2 squared is 4 times 1/2, and then 4 comma 8 for simplicity's sake. Now what happens is, for this function, we're going to be bringing this downwards. So this point comes here, and it ends up looking much more broad, just like as if we were to do a horizontal. So it begins to look like this. Now there are subtle differences, but the main difference is more apparent on things like cubic functions, and the points are obviously different. Thanks for watching.